Hi, I'm Adolph Oliver, and this is the video about how you add and subtract fractions with unlike denominators. Well, whenever you combine fractions, and that is you add or subtract them, the pieces, meaning each fraction, must be the same size because you've always got to be combining same size pieces, whether you're adding or subtracting. That means you need to have common denominators. And of course, it's the LCD that you want to convert these guys to. Okay, if your fractions do not have common denominators, then you have a little bit of extra work to do. Let's remind you of the steps that need to be done here. Okay, the first thing is you need to determine the LCD for all the fractions. Once you figure out what that LCD is, then you convert each fraction to that LCD. Now that means that you have the same size pieces when you do that, and then you can go ahead and add and subtract the numerators to get your answer. Of course, now we do have that standing rule that all fractions as final answers must be reduced. So the last thing, of course, is check to see if you can reduce. Well, let's start with a beginning example here, something that's not too difficult to work with. We got two fractions being subtracted from each other. 6x over 4xy minus 5 over 4x. Now they're close to having the same denominators, but not quite. We can see, for instance, here that the difference is this first guy has a y and the second guy doesn't. Well, here's what you can do. We can always multiply the top and bottom of any fraction by the same thing. For instance, if I multiply the second fraction by y over y, isn't y over y equal to 1? Yes. Do you ever change the value of anything when you multiply it by 1? Well, no. You can change what it looks like, but officially it still has the same value. Okay, so if we do that, let's scoot up a little bit more here and we can see what we end up with. Remember, this first guy was at our LCD, 4xy downstairs. The second one now, since we're multiplying top and bottom by y, upstairs I've got 5 times y, and downstairs 4 times xy. Well, okay, we now have common denominators here. And the first thing we do is say, okay, these common denominators, they're going to be the same common denominator that we have in our final answer here. So let me write down the 4xy. There it is. Now, the numerators, we just add or subtract. Notice they're not like. This is 6x, this is 5y. So the only possible thing we can do is just write them out like that, 6x minus 5y, all over, of course, the common denominator, 4xy. Well, okay, we have to see whether we can reduce this any. If there was some common factor that we could factor out of the upstairs here, but 6 and 5 don't have anything common and the x and y don't. So officially, to make this a single term upstairs, we have to play our old trick of putting parents around it, which reminds us then that this goes entirely as a complete package here, 6x minus 5y, and it would only reduce against something downstairs that looks exactly like that. Well, this downstairs guy is not like that at all. So here it is. Here's our final answer. You could leave the parents around the numerator if you wanted, or go ahead and drop them, but I like to leave them around because that keeps this to be a single term. And remember, of course, one of the rules about reducing fractions is you have to have single terms top and bottom. The bottom was a single term already. We made a single term out of the top by putting the parents around it. And since there's nothing common, that's all we can do right there. Okay, well now let's start looking at some more examples here of what we can do. And so Here's another one. Notice we are subtracting again. You can either be adding or subtracting the fractions. And the denominator is definitely not the same. This is 2x here, and this is 10x minus 8. Well, the first thing we have to do is figure out what the LCD is. So what we have to do is factor all the denominators. This first one, just 2 times x. Those are the two factors that it has, so we can't change it any. But there is a common 2 here in the second guy. I can factor out a 2, and that'll leave 5x minus 4. Okay, remember what we're doing here is reverse distributive law. We've factored out a common factor. And the reason we do that is so that we can figure out what the LCD is. Well, this first guy, remember, was just 2x. That's its factorization. So the LCD here then that we're going to do on these guys is going to equal all the different bases. I have a 2, I have an x, I got another 2, and I got this quantity. Okay, so putting them back together, I said I have 2's, I have single x's, and I've got the quantity 5x minus 4. Okay, now notice they're all to the first power, so there's the LCD. Now, here's a way you can handle this when you're changing both of them. Rewrite underneath what the LCD target is you want for each. In other words, for this first fraction, I want 2x times 5x minus 4. Okay. Then there's a minus sign in between. And in the second fraction, I want the same thing downstairs, namely 2x times 5x minus 4. Now, how does this help you? Well, here's the game you play in this. Compare the old denominator to the new one. What is it that I had to multiply this 2x by to make it look like 2x times the quantity 5x minus 4? Well, the 5x minus 4. Okay, so there it is. That's what I have to multiply the top or the bottom here, this denominator, to make the new denominator, the common denominator I want. Okay, play the same game over here. What did we have to multiply the old denominator by to make the new one? Well, you can see the only thing that's missing here is an x, so I had to multiply by x. Now, why are you keeping track of that? Well, what's going to happen now is to figure out what the new numerators are, you simply multiply them by the same thing. So this first guy here is going to be 6 times this quantity 5x minus 4. Here it goes. Okay. And the second guy over here, I'm going to take the 4 and multiply it times the x, so I get 4x. Now, let's prove that these are correct. If you take a look at this first guy right here, if you were to reduce the 5x minus 4 is top and bottom, and don't do that, we want to leave them there, but if you were to reduce them in your mind, you'd have 6 over 2x left, which is exactly what we started with. Likewise over here, I could reduce the x's out, and it'd have 4 over 2 times the quantity 5x minus 4. So we can see that although these look different, they're exactly the same value as the original guys, but we now have this common denominator. Okay, well now, let's turn around and work on getting the final answer here. Remember, our common denominator here, the same for both, is 2x times 5x minus 4. Now, what we have to do is get the correct top for this fraction. And this is where you want to be careful. In the first numerator here, we've got 6 times the quantity 5x minus 4. Use the distributive law to multiply out what you get. 6 times 5x will be 30x. It's going to be positive, so I'll put a plus in front just to remind us of that. Then 6 times negative 4 is negative 24. Okay, this is the total parts that make up this first numerator. Now, you see the second guy here? There's a minus in front of the fraction, so we take and apply that to the numerator. Nothing to multiply out here, it's just negative 4x, so I write that down. Okay, these are all the numerator parts we got. Now we do is just combine these. I've got plus 30x minus 4x. Looks like I've got 26x. You could put a plus in front of that if you want. And then minus 24. Okay, so again, combining the x's, I end up with positive 26x and then the plain number minus 24. Okay, the next thing we have to do is see if we can reduce this any. Now the nice thing is the bottom here is already factored, so we just leave it that way. 5x minus 4, there it is. Now, notice we can factor something out of the top here. 26 and 24 are both even, so we can get at least a 2. I don't think anything more will come out of 26. 26 is what, 2 times 13? Yeah, okay, and there's no 13s here, so reverse distributive law, factoring out the GCF, I can factor out a 2, and what I'll have is 13x minus 12. Okay, let's double check that that's right by multiplying it back. 2 times 13x is 26x, 2 times negative 12, negative 24. Well, notice what happened here now. We got the top factored into a single term, the bottom factored into a single term. So I can go ahead and reduce here, and there is something that reduces. There's a common 2 that I can reduce both top and bottom. So once I do that, what's left in the top here is just 1 times this guy in parens, or let's put the guy in parens down here, namely 13x minus 12. And downstairs I've got x times 5x minus 4. Okay, well, many times people will multiply out, you know, the what's left here of the fraction, and on the top you can just drop the parens, and the bottom you distribute the x back in. But I like to leave it factored like this just so you can double check and convince yourself that there's nothing common that can be reduced. And so I would accept the answer just like this, although you'll often see folks multiply it back out again. But remember, if you multiply it out, you don't have single terms top and bottom anymore, so don't do any reducing. You can't. Okay, let's go look at another guy here. Scoot up the page a little bit more here. And here we go. I've got 2 over r minus 5 minus 4 over r minus 1. Well, you see these denominators? They are definitely different. So we do not have a common denominator at the moment. And of course, since we're subtracting, remember, if you're adding or subtracting, you need to have an LCD. Okay, well, first thing is factor the denominators so we can figure out what the LCD is. And the only way we can factor both of these guys is to play the old trick of putting parens around it. That makes it a single term because there's no GCF here. And the same thing on the second guy. So 2 different bases, that means the LCD here equals r minus 5 times r minus 1. Okay, there it is. Now, we want to convert both these guys to it. So we do the same process we did before. Make the 2 fractions here. Here we go. The minus sign in between means we're subtracting as they're supposed to be. Now, what we want for the LCD is this guy right here, namely r minus 5 times r minus 1. And the same thing for the second guy, r minus 5 times r minus 1. Okay, there's our LCD. We want to convert these two. Now remember, here's what you do to figure out the change that you have to make. Compare the original denominator to the new one that you have. Originally we had r minus 5, now we have r minus 5 times r minus 1. So you can see that we have to multiply by r minus 1. Take this one times r minus 1, we get this. Okay, well now that means of course that for the top here, you've got to multiply it by the same thing. So I'm going to just indicate it, we'll distribute it out in a moment, but 2 times r minus 1. Okay, here we go. Now notice, you don't want to reduce this, but if you did it in your head, if you reduce the r minus 1's top and bottom, you end up with 2 over r minus 5, which is exactly what you should have to start with. Okay, do the same thing on the second guy over here. Compare the old denominator to the new one. What's missing is the r minus 5. Here it goes. So we have to multiply the top by the same thing. And if we do that, we get 4 times r minus 5. Okay, here it is. Now, notice again, okay, that if we work this out, okay, what we'd have is we could reduce the r minus 5's in our mind, and we'd have 4 over r minus 1, which is exactly what the original guy was. So you always want to double check that and make sure you haven't goofed it up. If you reduce these guys in this step, they'd have to give you exactly what you started with. But of course, don't reduce them. We're doing this step so we've got our common denominator. Okay, well now, since we've done that, that means then that what we want to do is come up with our final answer here. And the common denominator for both these guys is r minus 5 times r minus 1. Okay, what do we have for the top? Well, this 2 officially has a plus in front of it. Remember, if you don't see a sign in front of a fraction, you assume it to be positive. So this is a plus 2 here, and we distribute that into both of these guys. So plus 2 times r is plus 2r. Plus 2 times negative 1 is negative 2. Now, to continue on what the numerators are here, remember this second fraction has a minus in front of it. So you take that minus and glue it to the 4 here, and it becomes officially a minus 4, and now you distribute that in. Minus 4 times r is negative 4r, and minus 4 times minus 5 is positive 20. Okay, well now we've got all the parts of the numerators here with their correct signs. So now let's combine them together and see what we get here. Okay, we had plus 2r here, and remember this one here was minus 4r, so plus 2r minus 4r, negative 2r. That takes care of the r's. Now for the plain numbers, I've got negative 2 plus 20, and let's see, positive is going to win by 18. So there we go. Okay, so there's our answer. Now, of course, we have to check to see if we can reduce anything. So we got to factor the top up here. We can factor out a 2, and there's a minus in front of the first guy, so I tend to factor out a negative 2. And if I do that, I'll get just r left on the first term. And then, what is it, minus 9 on the second? Let's double check that by distributing back to see if we goofed up. Negative 2 times r is negative 2r. Negative 2 times negative 9 is positive 18. We look good. Now, of course, copy down what the bottom is. It's all factored for us, so it's a single term. Here we go. Now, we look to see if there's anything we can reduce. Well, we got an r minus 9. If it would have been r minus 5 or r minus 1, we could have reduced, but it's different, so we can't reduce any of those, and the -2 is a plain number. No plain numbers down here. So there it is. We can't reduce it any further. Now, like I said, many folks would distribute this back out, multiply it out, and do the same thing on the bottom. Again, my preference is to leave it factored, and I'll accept the answer going either way. Okay, well now, that gives us a little bit more practice in some of those. Let's take a look now at something here with a little bit more to it, but the process is exactly the same. What we have to do is first figure out the LCD, and that means factor the denominators, convert the fractions to the LCD, then add and subtract the numerators, and then finally see if we can reduce the final answer. Well, these guys do not have the same denominator here, so we've got to factor this. Let's see, 3 will factor into both the 3 and the 15. And I got 2 x's here and 1 there, so I can factor out a single x. So if I factor 3x out, the first term I'll have x, and the second term looks like just -5. Now, let's double check to make sure we got this right. Multiply it back. 3x times x is 3x squared. 3x times -5, -15x. Okay, that looks good. This guy here, there's no GCF, so all we can do is just say, okay, put parens around it. There it is. Now, as always, let's figure out what the LCD happens to be. And we're using the multiples method here to find it. Take all the different bases. I see 3's, I see a plain x, I see x -5 and x -3. So put them down. If they show up more than once, you only put them down once. All of these guys happen to show up only once. And then times x -3. Okay, so there we go. That's the LCD we want. Well, the next thing we do then is we're going to set up both these fractions with that LCD we want, namely 3x times x -5 times x -3. Okay, there it is for the first fraction. Its common denominator. Well, we need the same thing for the second guy. 3x times x -5 times x -3. Now, the beauty of this is, again, it's real easy to see what it is that you have to multiply by what's missing. The old denominator, 3x times x -5, when we factored it, compared to what we want, the only thing that's missing is the r -3. So that means we had to take this guy and multiply him by r -3. Actually, not r, x -3. Okay, now that being the case, then that tells us what we do to the top. We have to multiply him by the same thing. So I've got 3x times x -3. Now notice again that if you were to reduce the x -3's out, you'd end up with 3x over 3x times x -5, exactly what you should have. Okay, same process on the second guy. Compare the old denominator to the new one. What do you have to multiply this old guy by? Well, the 3, the x, and the x -5. So 3 times x -5. Okay, well now, that means we got to multiply the top by the same thing. So I'm going to have 6x times 3x, okay, times x -5. Now, once again, if you were to reduce out the x -5's and the 3x's, you'd have 6x over x -3, and that's exactly what we should have here. Okay, we've got the common denominators, so we're ready now to start working on the final answer. I can get ready for it by making a fraction here And I'm going to write downstairs the common denominator that we have. Okay, times x minus 5 times x minus 3. That's the same in both of these. Now, the next thing we have to do is distribute in. Get to figure out exactly how much we have for each of the numerators. Remember, if you don't see a sign in front, it's officially a plus. So we take that plus and glue it to the 3x. So this is plus 3x, and then we distribute that plus 3x in. Well, plus 3x times x plus 3x squared. Okay, plus 3x times negative 3. We got a total of negative 9x. Huh? So let's double check this to make sure we're right. Okay, remember, we had plus 3x times x, going to give me plus 3x squared, plus 3x times negative 3, negative 9x. Okay, looks good. Now, this guy here, here's what you do. Multiply together these first parts right here. We get 18x squared. Now, that's what you turn around and go in and distribute to each of the guys on the inside. So I'm going to have 18x squared times x, so positive 18x cubed. Okay, then 18x squared times negative 5. 5 times 18 is what? I think 90. So minus 90x squared. Okay, there we go. Okay, well, we got to combine the terms that we have here. Notice we've got an x cubed term, so we'll put that in front. Plus 18x cubed. Okay, then the x squareds, plus 3x squared, minus, what do we have here? Minus 90x squared. So that's going to be what? Minus 87x squared. Okay. And then we have just a plain number we got, which, well, not that, it's the x power, negative 9x. Here it is. Okay. Well, now, remember, we got to check to see if we can do any reducing here. So, let's continue on here. Here we go. Okay. There is a common 3 I can factor out of all of these. Let's see. Can't get a 9. 9 won't go into this. And 6 won't go in these others, so it's a 3. And then we can factor out a single x, okay, because we got x's in all of them. So what's going to be left when we do this? I'm going to have 18x squared. No, not really. I factor a 3 out of the 18. It's going to be 6x squared. We'll double check this in a moment. Minus, now I'm factoring out a 3x. So 3 goes into 87. Let's see, I think it's 29 times, huh? And then we have a single x. And then on the tail end here, factoring out the 3x there, it leaves me just minus 3. Now, something like this, you definitely want to check. If I take 3x times 6x squared, I'm going to get 18x cubed. I take 3 times negative 29, that's going to give me negative 87 and x squared, and then 3x times negative 3 will give me negative 9x. Okay, so that looks good. Now, let's put down what we have underneath here, namely 3x, this is our common denominator, times the quantity x minus 5, times the quantity x minus 3. Okay. Well, now, we can see we can reduce the 3 and the x's, no problem with that. This thing here is not going to factor nicely. So we're going to assume that we can't factor that further. We'll learn more about the quadratics as we go on. But we can reduce the 3's and the x's. So what I could do then is say, for the final answer on this one, it equals what we have upstairs here, 6x squared minus 29x minus 3, okay, all over, and I'm going to leave the bottom just factored like this, x minus 5 times x minus 3. Now remember, some folks would multiply out the bottom here and drop the parens on the top. But if you do that, you don't have single terms left anymore. So make sure you don't do any reducing. Reducing can only be done when you have a single term top and a single term on the bottom. Okay, let's look at one last guy here. Here he comes, because sometimes you'll see something like this. So let's talk about how we can do it. You got a fraction here, but minus the whole number. Well, if one of the guys is a fraction, you got to make fractions out of everybody. So what you do is make a fraction out of 6 by putting a 1 underneath it. Now, the next thing we need to do is factor the bottoms. This is just a plain 1 here, so no problem with that. But factor this guy, and there's an LCD here to begin with. I can factor 6 out, and that'll leave me with x squared plus 5x minus 6. Okay, so let's see, what do we got here? Double check this, 6 times x squared, 6x squared, 6 times plus 5x plus 30x, 6 times negative 6, negative 36. And of course, this guy is just a 1 over here. Okay, so the LCD, simply enough, is just this guy right here. Okay, so I got to convert this fraction to it. And what we can do in a case like this is simply multiply both top and bottom by that same guy, namely 6 times x squared plus 5x minus 6, okay, and multiply the bottom by the same thing, 6 times x squared plus 5x minus 6. Now notice again, numerator and denominator are the same here. So that means this fraction, although it looks real crazy, is really just equal to 1. And anytime we multiply somebody by 1, we're not going to change its value. So what we can do now is say, okay, this first guy right here, okay, he was already at the common denominator, so I just copy him down the way he is. X minus 2 all over, and I'll put the factor form downstairs. 6 times x squared plus 5x minus 6. Okay, now minus, now over here I'm going to have 6 times, and in the parents here, 6x squared, 6 times again, x squared plus 5x, okay, minus 6. Okay, and that of course is over our common denominator here, namely 6 times x squared minus 5x, oops, I should say plus 5x minus 6. Okay, now once again, notice that the top and bottom here of these guys, you could reduce the 6 times all of this, the same as this. If you reduce this guy against this guy, you'd have 6 over 1, or just 6 left. So that's exactly like we have it there. Okay, here we go. Now, let's start getting the final answer. We've got a common denominator, so I can write it's one fraction here. 6 times the x squared plus 5x minus 6. Okay, what do we have up on top? Well, remember, officially there was a plus in front of this fraction. Now that means the plus gets applied to this whole numerator. So I'm putting parens around the numerator just to indicate that we're going to hit the whole thing with the same plus sign. And when you do that, taking a plus and distributing it in doesn't cause any change here. In other words, we're going to end up with plus x minus 2. Okay. Now, this next guy. Notice what's going on over here. Okay, and I need one extra set of parens here. There it is. I've got 6 times 6 here, which is 36. So I can think of this as 36 times the x squared plus 5x minus the 6. Okay. Now, let's distribute this in to see what we get. And I'll have to write them up here in the corner a little bit. But remember now, there was a minus in front of this, so this minus gets glued to the 36. So I've got minus 36 distributed in. This is negative 36x squared, negative 6, or negative 36 times 5x, minus times plus gives me a minus. Okay, and we've got the 5x here times 36 is going to give me what, I think 180. Okay, of the regular x's. Okay, and then minus x times minus 6 plus 6x. Okay, let's double check this to make sure we got it right. I took the 6 times 6 to give me 36. Negative gets applied to that, so this is really a negative 36. Distribute it in here. Negative 36 times x squared. Negative 36 times plus 5x will give me negative, and 36 times 5, 180x. Okay, and then 36 times negative 6. Well, let's see. 36 times negative 6. I didn't have this correct on the end. It's going to be negative, and 36 times 6. Let's see, that's 180 and then another 30. I think it's 216. Okay, this is what you double check to make sure that you get these correct. Again, 36 and negative 36 times negative 6. That's going to be plus 216. So you have to keep checking that. And of course, 36 times 6, I think, is 216. Okay, well now, let's combine what we have. We only had a plus x and a minus 2 from this first guy. So I've got negative 36x squared. Put this in descending order. There's my x squared. Okay. Then I have minus 180x, but I had plus 1. So that's going to be minus 179x. Okay. And then remember, we goofed it up the first time, but this was plus 216 minus 2 plus 214. Okay. Okay, well, here we go on this. This guy in the bottom, I think we might be able to factor. But that would only give me a couple of binomials. And this guy on top up here, let's see, there's not a common 3 that will go into this. And so this one's not likely to be able to factor into a couple of binomials, so it doesn't cause any need to do this. So we're basically looking at the final answer here. Okay. We have the top all multiplied out. Can't really do any more. If we wanted to make a single term out of it, remind ourselves we put the parens around it. And then downstairs here, this is factored out even if we could factor this in a couple of binomials, I don't think you'll get any binomials out of this. So here we are, our final answer. Well, you can see that there are a series of steps that you go through here to be able to solve these guys. Let's remind you again what they are. The first thing you have to do is factor the denominators so you can figure out what the LCD is. Then you convert the fractions to that LCD. Here we go. Then finally add and subtract the numerators, the terms that you get, and check and see if you can factor the final answer, because anytime you have an answer that's a fraction, you must reduce it.